Hello and welcome to QCC. Hello and welcome to QCC. This is a project in which we will create C compiler from scratch in the D programming language without using any parser generator or Lexer generator, anything except the stuff we have written ourselves. Let's begin. I'm a slow typer, so I'm going to explain the code I have already written, and this has further advantage that you can read ahead in the code while I'm explaining, and you don't have to wait for me to type this stuff out, and I don't make mistakes while coding and can concentrate much better on what I am about to explain. Alright, let's start. What I would have written if I were typing it right now is exactly this. I would have written this writeline statement, which just is like printf in C, but it automatically appends a new line, so this one is not needed. It automatically appends a new line when it writes stuff out, and it will just write this string constant welcome to the QCC compiler. Then I would have written an input for our compiler, which is this string called source, which is just normal hello world program in C. We include stdioh, define our main function, call printf in that main function with a string literal, and return 0 because we are good little guys and want a defined return value. Good. That's it. Then the program will write out the source, and then it will write the line tokenized output. Then it'll create a Lexer. Right. So first I would have written this Lexer. So we go to the definition. This is something I wouldn't have started with. What I would have done would be would have asked myself what state is needed in a Lexer. And the state that is needed is the source I'm working on, the line I'm currently on in the source string, the column I'm currently on the source string, and the position I currently have in the source string. And those all have associated comments. You can see them highlighted when we are on the variable. They just say what those state variables are. Okay. Then we have a function that returns an array of tokens. This is just like in Java you have this array notation. This is a function called lex, takes in a source string and puts out this token array. So in here we enter a while loop. We say while the current position in the string is smaller than the length of the string. So while there is string to process, we want to get a token. If the type of that token, what that is we will get later, is not 0, so it is not an invalid token. I could actually write this out, and I will do this. Token type dot invalid. Alright, if we do not have an invalid token and the return value of get token to what we will return. Else, search 0 basically says throw an error here, because this 0 will always evaluate to 0 and will always be false. This will always be thrown if this statement is executed. We could make an assertion instead of the if, but assertions will only be triggered in debug, and that is not a good way to write programs, using asserts, making sure that the input is not wrong, or always assuming valid input is not the way to go. When we are finished with the processing, we set our source to an empty string, we set our line to 0, we set our column to 0, and we return the token array. This getStringID function is used for string interning. We'll get this later. This is the getToken function that is called by our Lex function. And first it asks if the position we have in the source is equal to or greater than the length of the source. So if we are at the end of our source string, return this token cast char -8. This token cast char -8, we will just replace this by the actual enum here. This is not invalid, it is EOF, end of file. So if we are at the end of our source string or even behind it, we will return the end of file with the current line, the current column. So this here, this underscore source equals source position dot dot $. This is so-called sliced expression. If we have an array, then we can do this. We can say, I want this array to encompass a subset of the array that goes from position to $, where $, usually means the length of the array. In this case, I want this thing here, this slice. I want this slice to be whatever source is from position to end. And this basically chops off part of the source string. Okay. Then I say char c equals source, this thing here, this chopped off thing, and I want the first character in this bit to be, I want it to be assigned to C. Okay? And then I switch on this character. If this character is a hash, I think we are in a preprocessor token. So I will call the lexpp function, which will deal with preprocessor directives. If the first token I see is a bracket or a brace or parens or a dot or a semicolon or a star or a comma, I will increase the position I'm on. So the cursor in our source file advances past this thing, and then I will return a token with this character C in the line we're currently on, the column we are currently on, and then I will increase the column, because column and position always have to be increased in tandem. It would be better if we would create a function to, I know, advanced cursor or something like that, that always does this for us, because if we increase position or if we just increase column without increasing position, we will get problems. If we discover a quote as first character in our input string, we know that we have to lex a string constant, and we call the lex string function. If the first character in our string is an underscore or the letters A to Z, you can see them here all enumerated, then we know we have an identifier and we lex that. And if the character we see is 0, a number from 0 to 9, we know that we have an integer literal and we will lex that. If the first character we see is a space or a tab, we just increase the position, increase the column, and call a function getToken again. Okay, if we have a new line, then we increase the position in our file to advance our read cursor in this file, so to speak. We increase the line count because we just have encountered a new line, so a new line must be starting, so we can increase the line count. And we set the column number to 0, because when we just had the new line, we have to return our carriage. That is basically this column thing. And then we don't put a token out, we just return getToken to basically skip this. Okay. This assert here gets triggered if the input does not match one of the cases enumerated here, and we know that we currently don't lex this token. Okay. Our first function is lexpp, lex preprocessor, for this preprocessor directive. Okay. We first assert that the character we have is really the hash, just to make sure that nobody called lexpp at a position where it shouldn't be called. This is just defensive stuff. We could omit this, but why should we? This makes our programming safer, and asserts are stripped out in release mode, so when we compile this in release mode, we won't have any performance penalty because of that. Now, the next line called lex identifier.